We're on Chapter 8, Lesson 1, Function Tables. Please turn with me to page 579. So, let's talk about a function. A function, oops, there we are with the blue pen again. A function has an input which results in an output. So, for every input, you have an output. That's as simple as a function is. Let's look at the real world problem. In science, a ruby-throated hummingbird beats its wings about 52 beats per second. Make a table showing how many times this bird beats its wings in 2 seconds. So if it beats it per 1, then all we have to do is multiply by 2 and we get 104. Make a table to show how many times it beats its wings in 6 seconds. So again, we input the 6 times the 52. 52 times 6, that's a 2, that's a 1, that's a 1, that's a 3, 312 times. And then how many in 20 seconds? 20 times 52, so again we have 20 seconds. And then that would be 1,040 times. And then lastly, a giant hummingbird beats its wings about 10 times per second. Make a table to show how many times it will beat in 3 seconds. So the input is 3 seconds. We know it's 3 seconds and 10 times for each second. So then it beats its wings 30 seconds. Turn the page. Alright, so now we have some really important vocabulary. A function. A function is a relationship where you have one output to one input. Exactly one output to one input. The function rule describes the relationship, and a function table just puts it in tabular form. Tabular. You have an independent variable and a dependent variable. Let's go ahead and write this over here. So independent, and then that would be your x variable, which is also called your input. Your dependent variable would be your y, and that is your output. So let's look at example number 1. The output is 7 more than the input. Complete the function table for its relationship. Remember when I said more than, so I already know that this is x plus 7. And then they're going to give me values for x. My inputs are 10, 12, and 14. I just need to add 7 to each. So 10 plus 7, 17. 12 plus 7, 19. And 14 plus 7 is 21. Notice that the change between them is 2. So again, just looking at the consistency, I can guess based on the fact that my input is increasing by 2 for each 2 numbers, because the spacing of this is also 2. Are there any questions there? Great, let's look at example number 2. Alright, in example number 2, the output is 5 times the input. Times, so that would be 5x. Complete the function table for this relationship. So, again, we're multiplying everything by 5. And again, we've got a spacing of 2. So 8 times 5, 8. Oops, sorry. We always put it in the order that the function is. So it's 5 times 8, which is 40. 5 times 10 is 50. 5 times 12 is 60. Notice these are going up every 10, because again, my spacing is every 2. So we have 40, 50, and 60. Now it's your turn. Ready, go. Pause the video. Did you get what I got? For A, I got 0, 3, and 6. And for B, I got 0, 6, and 15. Again, it's not that hard. You just have to put the input into the function rule and then get your output. Turn the page. Alright, so the other one we were finding the output. Now we're going to find the input. And to find the input, we have to do what we call opposite operation. This is just like doing those equations, remember? We have to do opposite or what we call inverse operation. So remember, if we have addition, to undo it, we subtract. If we have multiplication, we undo it by division. So again, remember, it's the opposite operation to come back. So if I look at this equation, it says 3x, which is 3 times x. To go back, I'm going to have to divide by 3. Notice I'll put an arrow in the direction that I need to go. And I'm going to divide by that. So in this case, I have 6 divided by 3, which is 2. And then if I go back the other way, 3 times 2 is 6. So it answers my question going back the other way. This would be 15 divided by 3 going back. So my answer is 5. This one would be 21 divided by 3, which gives me 7. So again, I'm doing the reverse going back. Now, I'm going to erase these because really you can't write that like that. I just explained it that way, but then you come back when you know what you're doing and you put it back the way the function is written, which is 3 times 2, which is 6, you're checking it. 3 times 5 is 15, and 3 times 7 is 21. So you do the operation in reverse, and then you go back the other way just to make sure that your answers are correct. So again, to undo an output, you have to do the opposite operation. Now it's your turn. Give it a try. Oh, before you give it a try, let's explain these because these are actually two-step. So in this case, when I draw my arrow, I'm going to add 1, and then I'm going to divide by 2. Add 1, I have to go from the back to the forward. Remember when we did the two-step equations the other day? So again, we added or subtracted first, then we multiplied or divided second. So I'm going to add 1, divide by 2. So let's look at D real quick and see if you can come up with what you need to do. If I have a 3x plus 2, the reverse of 3x plus 2, Will, can you answer that? What is the opposite of plus 2?
Minus 2.
Minus 2, very good. What is the opposite of multiply by 3?
Divide by 3.
Great. So again, when you're going from output to input, you're going to do the reverse or opposite operations, starting with the add, subtract, and then going with the multiply, divide. Okay, so now it's your turn. Pause the video. Okay, so did you get what I got? For the inputs I got for C is 1, 2, and 3, and for D is 5, 6, and 9. And again, the way I do this is I'll mentally do the math. So let's do C first. The output was 1, so 1 plus 1 is 2, divided by 2 is 1. Then I come back through the problem just to make sure that the math is right. So 2 times 1 is 2, minus 1 is 1, that checks. Again, 3 plus 1 is 4, divided by 2 is 2. 2 times 2 is 4, minus 1 is 3, so that checks. Now let's come over to D and just do the same thing. I'm subtracting 2, dividing by 3. So 17 subtract 2 is 15, divided by 3 is 5. 3 times 5 is 15, plus 2 is 17. And the last one, if it's 29 minus 2 is 27, divided by 3 is 9. 3 times 9 is 27, plus 2 is 29. So again, when you're given the output, you have to do the opposite or inverse operations to solve for the input. Then you put your input in and come back left to right to make sure that your inputs actually are correct. So let's keep going. Okay, so now we have a word problem. The Gomez family is traveling at a rate of 70 miles per hour. The function rule that represents the situation is 70x, where x is the number of hours. Make a table to find how many hours they have driven at 140 miles, 280 miles, and 350 miles. Then graph the function. So when we do this, again, we're just inputting in the x value. So if the input is 2, 70 times 2 is 140. 4 times 70 is 280, and 5 times 70 is 350. And again, it was easy going back the other way because these are all multiples of 7 out of 0. Now, because this function, 70x, the x is to the first power, we know that this is going to be linear. I'm going to erase that and rewrite this. It's going to be linear, L-I-N-E-A-R, linear or aligned. So I know that when I graph it, if my dots are off, I won't make a line. When I graph this, I should have a line that comes through here. And there it is. We always start at the apex or the origin. This is called the origin with your line. Now, some of them may start a little higher depending on where the number is, but in this case, we know that this one starts at 0, 0 and runs up. So again, a input to output, output to input. Input to output is straightforward. From output to input, you have to do the reverse operation or the inverse operation, and then you plot it. When it's first power, it's going to be a linear operation or a line. Okay, turn the page. So now it's your turn. They'll give you the output and the rule, and you're to find the input and then graph it. Pause the video. Did you get what I got? So they gave you the output of 12, 36, and 48. We know that in this rate, for the input is 1 hour, 3 hours, and 4 hours. Then I come over to the graph. This is always your x, and this is always your y. And then I graph, I place dots for each one of those values, and then I draw a line. And I came up with a linear function. So now it's your turn. Please do the guided practice. When you come back, the answers will be here.
Pause the video.
Did you get what I got? Again, on the first one, they gave you the input, you had to find the output. So for every 2 pounds, it costs $8. For 3, it's 11. For 4, it's 14. And then in number 2, you had to do the inverse. So if it's multiplied by 4, you're dividing by 4. They gave you 8 miles, it's 2 hours. 12 miles, 3 hours. 20 miles, 5 hours. You graph it linearly. You have a straight line. And then the last question. How can a function table help you find input or output? It's visual. Tables are really great because you visually see what's occurring. Thanks. Hope you enjoyed the lesson.